हेलो एवरीवन, हेलो। आई होप आप लोग अच्छे हो and you people are solving questions, learning things, building your concepts. Let us add one more to this series. So let us focus on the question. In a two-dimensional space, the potential energy function for a conservative force acting on a particle of mass m is given by this. So we know that whenever we talk about potential energy, we feel like, or we assume, or this is a fact, that there must be conservative field. Done it? Because from conservative field only we get the concept of potential energy. So inversely that is also true कि अगर potential energy function दिया है, we can talk about conservative field and that is conservative force here. So conservative force का value क्या होगा? देखो potential energy दिया हुआ है 2x plus y. So what is the force acting on the particle, on any particle, if that is present in this field? Then that will be treated as F equal to minus of dy dx of u I cap plus dy dy of u j cap. And dy dz करने की जरूरत नहीं है. Even if you do that, let's write it here k cap, because there is no u as a function of z is not given, z variable is not there. So finally when you will be calculating du by dz, you will be getting 0, because when we differentiate potential energy as x with respect to x, let's say, in that case we are assuming y and z as a constant. So when we are differentiating u with respect to z, we are treating x and y as constant. And here in u only x and y thing is there. अगर उसको मैंने constant मान लिया तो u constant हो गया when it comes to z thing, right? So in that case d by dz क्या हो जाएगा? 0. So that is why I was excluding it already. But let's go with this. अब देखो क्या होगा ये d 2 को बाहर ले लो, dx plus y by dx I cap plus d by dy x plus y, ठीक है, and this is 0, right? So इसको ऐसे लिख लो. Now this will be how much? Minus 2 dx plus y by dx. So dy by dx of x plus y कर रहे हो. Here you will be treating y as a constant. Then this will become simply differentiation of x with respect to x. So that will give you 1. So I cap only here. And here also you will be getting only j cap. So force is how much? Minus 2 I cap minus 2 j cap. This is the force. If some particle is there in this field, then this is the force acting on it because of this conservative field. Now let's talk about further. Question में क्या कह रहा है? The particle is being moved on a circular path at a constant speed. So it is moving on a circular path, constant speed. So uniform circular motion का case है. And the equation of circular path is given. अब देखो circular path का equation ऐसा है तो circle कैसा होगा? It will be centered at the origin and its radius will be equal to 4. बिकॉज दिस इज 4 का स्क्वायर, क्योंकि हम जनरल इक्वेशन क्या लिखते हैं? x माइनस ए का स्क्वायर प्लस y माइनस बी का स्क्वायर equal to r का square. This is the general equation of circle. Here a is 0, b is 0, so that is centered at 0, 0, and radius is here r का square के place में क्या दिया हुआ है? 4 का square. So you will be saying radius is how much? 4. Now what we are getting asked in the first case में हमें ये निकालना है, find the net external force that must be acting on the particle when the particle is at 0, 4. So let's talk about when the particle is at 0, 4, then what you can see. अब देखो यहाँ पे ध्यान से 0, 4 means this point, right? If we are treating it as y-axis, this as x-axis, so this is 0, 4. And at this point, because of conservative field, force acting will be how much? Minus 2 I cap, that is in this direction. So 2 Newton in this direction, minus 2 J cap, that is in this direction. So this is this. Okay? But we are asked find the external force other than conservative force. So we need to understand कि external force की जरूरत क्या है यहाँ पे. We need to explore that. So let's explore that thing in here. क्वेश्चन में क्या कहा गया है? क्वेश्चन में कहा गया है दिस इज अ यूनिफॉर्म सर्कुलर मोशन, एंड इन केस ऑफ यूनिफॉर्म सर्कुलर मोशन देयर वोंट बी एनी फोर्सेस एक्टिंग टेंजेंशियली, राइट? टेंजेंशियली फोर्स एक्टिंग शुड बी 0, अदरवाइज दैट विल एक्सेलरेट इट. सो यहाँ पे आप ध्यान से देखो, टेंजेंशियली 2 न्यूटन का फोर्स है. सो एक्सटर्नल फोर्स मस्ट बी एक्टिंग इन दिस डायरेक्शन, one external force in order to balance this, so that should be of 2 Newton. And what else? और भी देखो क्या होगा. सो एक्सटर्नल फोर्स और क्या लगना चाहिए? सो लेट्स ट्राई टू सी कि ये जो 2 जे कैप लग रहा है टुवर्ड्स द सेंटर, इज इट इक्वल टू सेंट्रीपिटल फोर्स रिक्वायर्ड हियर और इज इट ग्रेटर देन दैट? अगर ये ग्रेटर है तो उसको बैलेंस करने के लिए मुझे इधर फोर्स लाना पड़ेगा, ठीक है, सो वी नीड टू चेक विद दैट. सो सेंट्रीपिटल फोर्स रिक्वायर्ड हियर, एफसी रिक्वायर्ड यहाँ पे कितना होगा, दैट इज इक्वल टू योर एम बी स्क्वायर बाय आर. So m कितना होता है 0.1 given in the question, v is what 1, r is what 4, so this is equal to 0.025 newton. So this is only this much. So I mean some force would act towards the center which will be responsible for taking it into the circle, and that force here is the component of, I mean a part of conservative force acting in the j cap direction at this point, so minus j cap direction. So टोटल कितना लग रहा है 2 जे कैप, इसका ओनली 0.025 पोर्शन कहाँ जाएगा तुम्हारा, दैट विल गो विथ, दैट विल गो टू प्रोवाइड सेंट्रीपिटल फोर्स. रेस्ट का क्या होगा, रेस्ट को तुम्हें बैलेंस करना पड़ेगा टू मेक इट यूनिफॉर्म सर्कुलर मोशन. ठीक है, सो दैट वी कैन डू बाय अप्लाइंग एक्सटर्नल फोर्स इन दिस डायरेक्शन. सो कितना लगना चाहिए 2 माइनस 0.025 न्यूटन. Done it? So this will be equal to how much? This should be equal to 1.975. So this is your 1.975 Newton. So what are the external force acting? So external force acting is 2 Newton in I cap direction. So 2 I cap plus 1.975 J cap. So this is the external force acting at this point. Okay. Now let's move on with the B. Calculate the work done by external force in moving the particle from 40 to 04. सबसे पहले potential energy function लिख लेते हैं. This is 2x plus y. Now in moving from 40, यानी कि 40 is this one, 04 is this. Now work done by all forces is equal to what? Change in kinetic energy. We know this work energy theorem. All forces here, two sort of forces are acting. External force, we don't know the nature of it. Another is your conservative force. So that is delta KE. Now what is the case here? Work done by conservative force को हम क्या लिखते हैं? That we write equal to negative of change in potential energy. So that you write here, and here you will say work done by external force is equal to change in potential energy plus change in kinetic energy. Change in kinetic energy is 0 because it is uniform circular motion. Velocity का modulus is constant. It means change in kinetic energy is 0. Now let's talk about delta U. So at this point, potential energy will be how much? This will be equal to 2x plus y. X plus y क्या है? 4. And at this point, if you calculate potential energy, U is how much? Again 2 into 4. Okay? So at these 2 points, potential energy is same. That change is also 0. So overall work done by external force will be what? 0. I hope you have understood this question. यहाँ पे कुछ ज़्यादा नहीं करना था. You simply needed to pick each and every concept, and then you needed to explore things and analyze questions properly, and then you needed to apply things to get the answer. So I hope you have got this. Even if you are stuck somewhere, you feel like you couldn't understand some portion of it, you can always let me know in the comment section. Thank you. Take care of yourself and keep solving more number of questions.